Hello, welcome back to Learning Economics with Sadaf. Today I've decided to do an intermediate macroeconomic question where we need to maximize utility by using Lagrangian function. Okay, so before I go into Lagrangian function, let me give you a quick idea about consumer satisfaction and how we can find optimal amount of good X and good Y from here. In that case, let's assume that good Y goes over here, good X goes over here. This straight line represents our budget constraint or budget line. In that case, I'm going to first write budget line using the information that is given to us. Price of good X and price of good Y is given over here. Let me write down general version of budget constraint first. Price of good X times with units of good X, price of good Y times with units of good Y, that needs to be equal to total income. Now we know that information is given to us in this case. So I'm going to just plug this information in. 20 times X, 40 times Y, that needs to be equal to 100. That's our budget constraint. And then indifference curve or utility function is given to us as well. In that case, we're going to write down xy, which is x plus 1 multiplied with y plus 1. Graphically, that's the point we are after. We need to find the intersection point of utility that represents satisfaction of a consumer and budget constraint. From the name, it represents constraint of income for a person. Keeping in mind that there are these two limits a consumer faces, we need to find optimal number of good X and Y or a bundle of these two goods that would make this consumer satisfy. There are two ways of finding this. One way is use the maximizing condition where MRS will be, or MRS is MUX over MUY, that will be equal to price ratio. That's easier, or one way of finding it out. Second is establish it through Lagrangian function. So the theme of this video is to do it through Lagrangian function. I'm going to first establish Lagrangian function and then we can find out optimal amount of good X and good Y from here. So I'm gonna step one for that would be establish Lagrangian function. Lagrangian function is L. I'm writing down its general version. It's utility of utility function minus lambda, and inside you will have budget constraint. All right. For that, budget constraint needs to look like this. You need to bring income on the other side, and it should look like this: 20x 40y minus 100. So in a way, we want to see that if total consumption is done by this consumer, subtracted income from that, nothing will be left from here. That's what we're going to plug in over here. Lagrangian function, now we know that utility function looks like this. It's x plus 1, y plus 1, minus lambda, and then plug this utility or budget constraint equation over here. Put it down, plus 40y minus 100. This is it. Now there are three unknowns in this. One is x, other one is y, and the last one here is lambda. We need to take derivative with respect to all three of these, and then from there we can find out equilibrium level of or optimal level of x and y. So now we jump towards step 2. Step 2 is take derivative. First we have x. I'm going to take derivative with respect to x, or before that, let's just get rid of these parentheses so that things would become simpler or easier for you to understand. X multiplied with y would be xy, x multiplied with 1 would be 1, xy plus 1 would be y, and 1 plus 1 would be 1. And I'm going to write down everything as it is. Okay. Now taking derivative with respect to x, we only get x over here, y would stay as it is, this would just eliminate, this would also eliminate, this would also eliminate, and in here we only left with 20. X would just eliminate, and then 0 and 0. Okay, don't worry about the sign. And from here, once I simplify it, I get y, I get 1, and I will get 20 times x. Nothing, 20 times lambda. X would just eliminate. This whole thing will be equal to 0. I can simplify it by saying that y plus 1 is equal to 20 lambda. Let's call it as our equation 1. All right, we can do the same thing for equation or for y as well. That would be a second unknown in this. Okay. So I'm gonna write down step 3 here would be take derivative of this function with respect to y. This whole thing, or look at that equation again, which is this simplified. First we'll simplify it, x would stay as it is, y would be 1 minus 1. Then x disappeared, y would be 1 minus 1, 1 would just disappear. Go inside this parenthesis, 20 times x is constant, it's not changing, it's going to be 0. and 40y would be 40y 1 minus 1, and 100 would just disappear. Right? So in the simplest form, it would be x plus 1 minus 40 lambda. This whole thing is equal to 0, or I can call it as x plus 1, which is equal to 40 lambda. Right? This is our step 3. Now we can move on to step 4. The third unknown here was lambda. Let's take derivative with respect to lambda. These, all of these are constant. They do not contain lambda, so I'm going to just replace 0 for every one of these. And for that, lambda would just become 1 multiplied with everything that's inside. In the end, we'll get budget constraint, original budget constraint over here. This whole thing is equal to 0, or we get minus 20x minus 40y plus 100, which is equal to 0. Bring minus things to other side, 20x and 40y. Let's call it as equation 3. This was our equation 2. All right, let's sort equation 1 and 2 from here and try to find one value of x with respect to other to make things easier to understand. Okay, so I'm going to write down equation 1 over here, which is y plus 1, which is equal to 20 lambda. I need lambda separate. Let's just divide 20 on both sides. 20 gets cancelled out. I have lambda equal to y plus 1 over 20. Alright, then I can bring equation 2 over here as well, which is x plus 1, 40 lambda. Let's get rid of lambda here from this side as well. 40 and 40 cancel out, and we have lambda equal to x plus 1 over 14. So that's our equation 4, that's our equation 5. You can see that left hand side of these equations are lambda, and lambda. That would mean that if left hand side is equal, right hand side of equation 4 and 5 would also be equal to each other. So I can write it down as y plus 1 divided by 20 is x plus 1 over 40. Right? Let's bring constant to this side and variables on this side. That would be y plus 1 over x plus 1. And on this side, we will get 20 over 40. Simplify it, and I'll get 1 over 2 over here, y plus 1, x plus 1 over here. Now we can cross multiply it. 2y plus 1 over here and 1x plus 1 over here. This would be 2y plus 2 x plus 1. Okay. Let's find the value of x in terms of y. Bring 1 to other side. That will be 2 minus 1, and we have x over here. 2 minus 1 is 1. We get 2y plus 1 equal to x. Okay. Let's call it as equation 6. So up until now, we have calculated that x can be written down like this. Now we can go back to budget constraint and put this value back into our budget constraint. So I'm going to say that put value of x in budget constraint that we have calculated in equation 3. Okay, so I'm going to say that put the value in equation 3. Equation 3 is 100, which is 20 times x plus 40 times y. Value of x is 2y plus 1. So instead of x, I'm going to write down 2y plus 1 plus 40. Bring 20 inside, that would be 40y plus 20 plus 40y. Right? And we have 100 over here. 20 is a constant, bring it to other side, and 40y and 40y, we can add them together. That will give me 80y. So 100 minus 20 is 80. 80y over here. Now divide 80 on both sides. And that gives me one value of y, which is 1. So that's the optimal value of y, which is 1 unit. So in order for this consumer to maximize its satisfaction, we are suggesting that this consumer go with 1 unit of good y. And then we can find equilibrium value of, or optimal value of good x as well. Plug value of y in equation 6. That's equation 6. 2y plus 1 is equal to x. Put in the value of y in here, and that's x. That's 2 plus 1. 2 plus 1 is equal to x, or x is 3. X star is 3. So from here, you are suggesting that the intersection point through Lagrangian suggests that y should be consumed as 1 unit, x should be consumed as 3 unit, and this bundle would make this consumer satisfied, and this consumer wouldn't want to change its deviation or decision over time. Right? And the last thing here would be, if you want to double check you are on the right track, you can put this value of y and x inside the budget constraint and check that if left hand side is equal to right hand side. So we have 100 20x plus 40y over here. Let's plug in value of x, which is 3, and value of y, which is 1 in here. It's 60 plus 40, 100, and on both sides you'll get 100. So both sides are equal, indicating that these are the optimal bundle of good x and y that a consumer should be consuming. And that brings us to the end of this video. I hope this was helpful. In the next video, I'll try to explain this first method, slope method, to find this optimal level of x and y. And I'll see you next time. Thank you so much.